Perfect.
So last time we were looking at the S matrix operator. So remember we're in the interaction picture, and our quantum state evolves by the interaction Hamiltonian. Whereas the operators evolve just according to the free Hamiltonian. And we were looking at, we're going from t is minus infinity to t is plus infinity. This is often used to describe scattering. And just generically, let's take our state, t is minus infinity, to be some initial state, and this evolves into a state at plus infinity, which is given by a unitary operator S acting on the initial state, and the probability, if I measure the final state, the probability that I find the state f is equal to f s hat I squared. So this is the probability for a transition from the initial to final state is given by this modulus squared of this matrix element. And we saw how S matrix operator can be written as a perturbation series so here we have the 0th order, 1st order, 2nd order, 3rd order terms, and we found an explicit expression for the 1st order term, and we were looking at some of its properties. So let's just pick up from where we were. So the 1st order term looks like this: minus I, the integral over space-time of the interaction Hamiltonian density. Okay, that's what it looks like. And given using our interaction Hamiltonian density for quantum electrodynamics, the interaction between the Dirac field and the electromagnetic field, we have IE integral d4x normal product of psi bar gamma mu a mu psi. So IE integral normal product psi bar gamma mu a mu psi, where these field operators are expanded in terms of plane waves just as before. Remember, I'm going to say this for one last time in the interaction picture. So because the field operators evolve just through the free part of the Hamiltonian, everything we've learned about the field operators stays exactly the same. The same expansion, same commutation relations, everything's the same. So what you do, the expressions, so these are in effect the free field operators. Even though we've got the fields are interacting, the interaction makes the quantum state evolve. Okay, the field operators evolve only according to the free part of the Hamiltonian. So the field operators still obey the free wave equations, the free Dirac equation, free Maxwell equation. All right, so I said that about 20 times on Tuesday. I promise I'm not going to say it again. Okay, good. So now, the field operator expansions here for psi is of the form C plus B dagger. Okay, it's a sum over plane waves. You have annihilation operators for electrons, creation operators for positrons. The A mu expanded in terms of plane waves is of the form A plus A dagger. Creation and annihilation operators for photons. And the psi bar is of the form C dagger plus D. You have creation operators for electrons and annihilation operators for positrons. Okay, so what we were looking at last time is what are the non-zero matrix elements. The non-zero matrix elements. All right, so we were looking at our first example. So there are various terms that so what you have to think here is, well, if I multiply out these series, I'm going to get various combinations of C's, D's, A's, D daggers. What are the possibilities? So what we were looking at, first we were looking at the following example.